Twitch. This is our first time actually doing a live stream. So today I'm going to be learning Fusion 360. And I brought along a friend who is actually pretty good at CAD drawing and doing this type of stuff. His name is Barrett. So everybody, welcome in Mr. Barrett.
Hi, folks. Pleasure.
So why would someone want to use Fusion 360? Just out of curiosity, because I know some people say, oh, I want to design something in for, say, a project like they want to design something up to print on the 3D printer. Why would you want to choose Fusion 360? What is its advantages? What is its disadvantages?
So from our earlier conversations, I know that the part of what you're asking me is why would you choose Fusion 360 over, say, Tinkercad? And the real answer is time and power. You can do a whole lot of interesting things in Tinkercad. You can make marvelous stuff, but you're missing a whole bunch of tools. Things like the pattern tool, the rib tool, the ability to loft, to put a draft angle on something. The amount of tools that you're not able to access because you're using Tinkercad. Tinkercad is a fantastic tool. I use it myself. If I'm just doing something quick and easy, although I can tell you 9 times out of 10 that quick and easy thing tends to blow out of proportion, and I regret using Tinkercad afterwards. But Tinkercad is very capable, but the tool set that's available in a full-fledged CAD suite is something else, and you don't have to be scared of those tools. Those tools can open up a world of possibilities, but you don't have to use them all right off the bat. Learning a couple basics can get you doing all the same things that you were doing in Tinkercad before pretty easily, and then the sky's the limit.
Yeah, and we're going to be doing this about once a week, every Saturday or Sunday, depending on when we do it. So we're going to first talk about Fusion 360. So we're going to go to my screen, and we're going to show you my setup so that you guys have an idea of what you're seeing when you first start Fusion 360. Because, well, Mr. Barrett here has it set up in such a way that he's able to have it so it's oriented. So when he starts designing, he can immediately print it. Where as a beginner, you're going to see that you're not going to see or have that option.
Actually, I changed it around so I can show them how to change that today.
Oh, okay. So we'll get into that, I guess.
Yeah.
Okay, so let's go to my screen first. And to first start a sketch, you want to go create sketch. This opens up your platform. So what am I looking at here exactly?
So what you're looking at here right now is the model space. So up in the top left-hand corner there, you'll notice it says design. And that big drop down there at the left that says design, that's how you change different modes. When you do go to, let's say you were going to start doing CAM or something like that, you might go into the manufacture setup. And but right now we're going to spend most of our time in the design space, which is the model workspace. This is where you're going to create solid models. So the first thing we're going to do, Ron has already clicked on Start Sketch. And then you've got 3 planes here, which represent the XY plane, the YZ plane, and the XZ plane.
Okay, so the first one I got selected, which is in blue. What plane would that one be?
So that's actually the top plane, which in your case is going to be, well, we're Y up here, so that's going to be the XZ plane.
Okay. This plane would be considered?
So that plane is currently the YZ plane. So you were on the XZ, now you're on the YZ, and that's the XY plane. So This is actually part of what I was going to talk about when we changed the view. Most modeling software uses a Y up scenario, which is what this is. The Y axis is the vertical axis, which relates to the common graph that you're used to seeing, the X axis and the Y axis, creating that traditional graph. And that is handy and convenient for modeling, except that when we go and place something into a 3D printer, and we're going to try to 3D print it, we actually want the z-axis to be the vertical axis. So what we can do is actually change that axis for you. So Ron, I'm going to get you to go and click on your name in the top right-hand corner.
Okay.
Hit Preferences.
Preferences.
Yeah. And under General, here, so if you click on the General, there is a little ways down, there's a thing that says Default Modeling Orientation. It says Y up. It's a drop down.
Oh, yeah, I see it says Y up, yes.
If you just change that to Z up and then apply, and that's going to change the orientation of those little boxes. So, so if you go ahead and apply that, now the way that I suggest doing this is close your model space.
Okay.
So just close that whole document, and it'll never let you have nothing open. It'll automatically open a new document for you, like it just did here. The reason we did that is just to make sure that that change is applied, because it won't necessarily apply to a document you've already got open and you're already working on.
Yeah, it looks like it has already, because I can see like a Z and an X.
So now it's applied because we did that. We closed that document. So now if you go to the sketch, you'll notice that the planes are going to be oriented a little bit different. They're kind of turned around from where they were.
Okay.
But now they're in the orientation. So if you make your model now with the bottom plate being on that, can you highlight the bottom plane there? Oops.
Sorry about that. I think I just exited out of that. We gotta recreate that.
So yeah,
this bottom plane right here.
Yeah. So that plane would be essentially the bottom of your object, or well, your bottom. The bottom will be wherever it is, but that is a representation of the plane that would be parallel to the surface of the bed.
Okay.
So another thing we should probably talk about fairly early on here is to go up to the top left corner there. You'll see document settings. Top left.
Sorry.
Down a little bit. You're down into the model tree on the a little below that, document settings.
Oh, there's document settings. Okay, yeah.
So drop that down. Expand that. Yep. And then you see that your unit's millimeters. So right now you've got your default preference set to be millimeters. But whether you've got your default set to millimeters or not, you can always change that value. So if you click on that, you'll notice a dialog will pop up. It'll probably be on the right-hand side of your screen when it does. If you click on the, click on the, yes, that.
Okay, there you go, millimeters.
There you go. So you could change it to inch. So if you wanted to change it for this model, you wanted to do something in inches, that's how you would do that. Word of warning, if you change that while you've already drawn some stuff, it will convert everything. So if you've drawn something to be 20 millimeters, it will convert that to be
inches.
Yeah. So basically, you really kind of want to make sure you get the dimensions, the measurements that you're going to be using selected at the beginning of your model. It'll save you a lot of trouble later.
So I guess this is good for someone who doesn't know the metric system, like the U.S. I think it's only the U.S. that takes the metric system, that doesn't use it.
You know what? Even the U.S. and the manufacturing world uses the metric system. If you talk to anybody in manufacturing, they know the metric system. But there are places and times where it's like you're building something, and it just makes more sense to use the inches. For example, when I do things that are carpentry projects, I will quite often design them in inches.
Yeah, because that's where, like a 2x4,
dimensional lumber sizes tend to be in inches. And I quite often go and use my father's workshop, and millimeters don't work for my father.
Yeah,
and a lot of woodworking tools are marked in inches and feet, and it's just easier to work with that way sometimes.
Yeah, because they've used it since then, so
yeah. So that's a very good thing to know. Ron, let's talk about the Viewcube next. off on the right-hand side there.
Okay, so we have like top. You're talking like where it says top and
Yep.
everything else here? Okay.
Well, I'm going to get you to click on that little home icon there first.
Okay.
If you click on that, that's going to give you your default orientation, which is an orthographic view, a isometric view. That's going to show you the model kind of from the side and the angle. But if you look at that Viewcube up there, so you can click on any side of it that you can see and bring it to you, including the corners.
Okay, let's say, so if I click on front,
click on
it'll bring me to the front view.
Snap you to the front view. Now, if you notice, there's also a little drop down to the right of it. Well, actually, before we do that, let's show a neat little one. There's, if you hover over it now, you'll see that there are little arrows to the side. If you click one of those, it'll go to the face that you can't see in that direction. There you go. See, just now you're looking at the right plane because you clicked on that. There's also two little arrows up to the top right of there that will let you rotate that cube. So let's say you happen to bring your cube in and it was oriented sideways and you wanted it to level it out again. You could click that to do it. There you go. So you just you have to turn the right on its side, but that's so if all else fails, this is a good way to get yourself set back up again. If you kind of get lost in your orientation.
And then you can just hit home, which would take you right back to the orientation, correct?
Yep. So that'll take you back to that default. You can change that default as well. There are the little drop down at the bottom. I don't want to get too complicated here, but this is just sort of what some of these parts are. So let's start off with a sketch now. So if you're coming from Tinkercad, or if you have any experience with Tinkercad, you were using 3D primitives, which would be things like a cube, a sphere, a cone, a ramp, as they would call it, you know, some sort of a 3D object, and you're replacing them together and using the way that they intersected. In Fusion 360 and in most professional 3D CAD suites, you're actually starting off with a 2D sketch to create the 3D primitives. So, but you're not locked into making the ordinary 3D primitives. Right now, we're going to walk through making some simple stuff. We're going to make a cube to start off with because it's one of the easiest things to do. But you know, once you learn how to use the sketch, you're basically drawing a cross section of something and then making it three-dimensional. And it's really just taking the thinking in terms of those 3D primitive building blocks and visualizing in your mind what the two-dimensional side view of that looks like. Oh, I can do that, and then I can extrude it. Or, oh, if I draw this cross-section, I can revolve it and end up with a cylindrical feature. So let's get started. We're going to make a basic cube here. So run, select a plane. It doesn't really matter which one at this point. And you're going to go ahead and use R for the rectangle tool.
Okay, just hold down R, is that correct?
Just click R. Yep.
Okay.
Press and release. Yep. And then he's already gravitating towards the origin there to anchor it, which is a good practice.
So what size would we want to go with? Maybe 25 by 25 or?
25 by 25 sounds good.
Okay, so, let's do that then.
And Ron actually, yep. So if you want to dimension that, do you remember how to do this?
I'm trying to remember it, but if you want to tell me how to do that.
Another rectangle right now. So if you hit escape.
Oh, yeah, escape. Sorry.
Okay. So now if you hit the D tool, that'll bring up your dimension tool. And you can select the two sides, or if you just select a face, it will give you the, yeah. So that, what you just did there is you selected between two lines, so you can lift that, raise that up, or enter that in as wherever you want. The other way that you can do this is just click on one side. So you don't want to do that one because you've already essentially given that dimension. So click on the right side.
Like this side right here?
Yep, just click on that one. Yep. And draw your dimension tool away to the, yep. And now click again and enter a value. So what we've done is we've now dimensioned that line. Instead of, so the first dimension that you did, you dimensioned between two lines, but now you've dimensioned the height of that one line. You see how that worked there? Now, I don't know if anybody noticed this, but as soon as you put in that second dimension, the blue rectangle turned black. The reason it turned black is because it's fully defined. Now, Fusion 360 knows exactly where this square exists in space because we latched it to the origin at 0, 0, and we gave it 2 dimensions, which coincidentally are, or purposely in this case, are from the origin. So it knows exactly how far away the edges of it are in space from the origin, and it knows where it is in relation to the origin, and it's got a dimension to the size. So it has all of the information it needs to mathematically compute where that square exists.
So why would we want to constrain it? Just out of curiosity.
The reason we want to constrain something is again so that the software knows where this is. If it doesn't know where it is in space, you can potentially move something else in relation to it and end up with an error because it's not got an exact dimension. So it basically is a way of letting you know that you've supplied all of the dimensions that the software needs to physically lock that in space.
So we're just locking in the size that we want to create, correct?
You're locking in the size and the location. So you're registering it within space, so that it has an absolute position. If you can start off and not do that early on, but it's bad practice and it will eventually bite you. So while it's really easy and you're working with simple objects, I suggest getting used to the practice, because as things get more complicated and you start making like really complex shapes, not having things fully defined will bite you every time. Been there, done that, bought the t-shirt. That's actually keeping everything fully defined is actually the thing you're probably going to struggle with the most. The actual drawing and design is actually relatively easy in this. We've just created a square, and watch how simply we turn this into a cube.
Okay.
If you want to hit the E key for extrude, we could hit finish sketch, but we don't need to in this case. E will automatically take us to extrude.
Okay, and I noticed that we have a whole bunch of sets on my side here. So what am I looking at exactly here?
So the options that you have there are giving you, so you've got a profile selected, it's telling you. It's telling you that it wants to expand or make that from the profile plane. We'll play with that one in a second.
Okay.
The next drop down determines whether it's going to extrude in one direction, 2 directions, or symmetrically to either side. So if you do one direction, it's going to, from your sketch, it's going to extrude out. If you do 2 dimensions, you can set it to extrude this way a little bit and then this way by a larger amount. If you do symmetrical, it's going to
do both of them at the same time.
Yeah.
Okay.
So for now, let's just do one side. And then the next one is distance. That 2 object stuff. If you have other objects in space here and you're trying to extend something up to connect to it, you can use that 2 object or through all. So then we can just put in a distance. So you said 25 for this, so let's make a perfect cube. Let's make it 25.
Okay.
And the taper angle there, we'll play with that in a second. We'll just do the extrude at 25.
Okay, and operation new body, do I need to change that at all?
Nope. So what this is going to do, because this is the first thing that we're going to create, it's obviously we want a new body. When you create additional bodies in space here, let's say if we were to create another cube next to it, we would have the option of whether or not we want to make that part of this or we want to have it be a separate entity. Most of the time you're going to want to join or cut, but there are times when you want a new body, so you can control that.
Okay, and I just hit OK then?
Yep. Okay, and you've got your cube.
Okay,
So,
yay, I got cube.
now
Woo.
we're going to go look down the bottom left-hand corner of your screen.
Okay.
There are some play buttons, which I don't tend to use those play buttons very much, but there's a timeline that started here, and you'll notice that there's a sketch, and there's also our first extrude.
Oh yeah, I
If,
see that right there. Yeah,
if you
extrude when I highlight it.
let's right-click on the extrude and go to Edit Feature.
Edit feature. There we go.
So
Oh, we
now
bring up our profile again.
it brought up that again. So let's change. I want to change something here. I'm going to select from the start. I'm going to change to offset plane, and then that's
Okay.
going to give me a value.
We'll go to your
And
screen then. Let's see it.
yeah, so I'm going to put in 25. So now what I'm going to do is I'm going to go over to the model tree over here, and I'm going to enable the origin so you can see the origin. So what just happened is I've offset the object by 25 millimeters. So if I go back to the profile plane, you can see that it dropped there. Offset plane, 25 millimeters. So I don't necessarily have to extrude an object from the sketch itself. I can draw the sketch and offset it from that sketch.
Oh, okay.
That might not seem useful now, but it will be later. So that can be fun. So we're just playing around with some of the options in here and showing you what these things will do.
So where does someone find that option that you just turned on? The plane view.
So the plane was in the model in the tree view over on the left hand side here.
Yep.
And I just went here and I dropped down the origin, and what I did was I clicked the visibility button here for the origin. So that made the origin visible. And the other thing that's happening here is the sketch is visible. So because the sketch is selected, it's showing the initial sketch. If I turn the sketch off and select, oh darn, offset plane. Sorry, I just monkeyed it up a little bit here. Sometimes it doesn't like you changing certain things in the middle of. It wasn't too happy with me having tried to adjust that while I was in the so it's turned my model negative 25 instead of positive 25. That's what happened there. So now if I do the offset plane 25, you'll see it again. Now you notice the sketch disappeared, and that's because we didn't have it selected. There's where the sketch is. If I turn the sketch on, you can see it. So controlling visibility of things can be useful. Most of the time, you don't necessarily want to see the origin. It can get in your way, but there are times when it's useful. If I was to start a new sketch, the origin becomes visible automatically as I need it, because I might want to start a new image on a sketch. But now I can start a new sketch on any one of the planes of my new cube. So I could start a sketch right on the front of the cube itself, and I could just draw a circle. And you'll notice that it's light blue, which is because it's not defined. It doesn't know how big it is. So the first thing I'm going to do is dimension it. So let's make this 12.5. And then I'm going to dimension it, its location, 10. And again, I'm using from the origin here. So, and now it's gone black because it's fully defined. Now I can hit this while I'm still in the sketch view, or I can finish the sketch and I can extrude. I have two options here. I can make this a positive item, so I can, yeah, 25.
Well, that's a little bit large.
Not 2,500. So 25. So there is my now peg. Let's say I wanted that to be a hole. This is one way to make a hole. I can just reverse the direction of this, and it will automatically want to flip to cut usually. But in this case, I just manually forced it. But now I can cut that through there, and we've got a hole. So if you're wondering how I'm rotating here, I'm pressing the Shift key, and I'm using my middle mouse button. that's allowing me to drag around the orbit view here. And then if I just click the middle mouse button, I can drag something from side to side. You want to try that, Ron?
Yeah, sure. So I'm gonna have to go into my screen then. Oops, looks like we just lost our host, but he'll be back in a second. It says device not connected, so we'll have to wait for him to get that all set up again. So if I remember correctly, he said I have to go oops. Shift. We're gonna move. I want to see that end. Let's see if I can remember how to do this. Right front. There we go. And we want to modify. So we're going to press C. C allows me to get into circle mode. So I'm going to grab a circle. We're going to make it big. Maybe we'll make it 12 exactly. So I'm going to lock that in there. And we're going to go, oops. No. Escape. We're going to go D. That we're going to make 12. And then we're going to go here. D again. Drag a line down. Drag a line here. We. Oh. So here we want to make this by, let's say we're doing a circle that's going to be in the center. So because we are using a 25 diameter, we should probably go with 50. No, sorry. Go with
you made a 25 millimeter cube, so if you want it to be, let's say, half the size,
yeah,
it's 12.5.
12 point. Thank you. And here, I type in 12.5. Is that correct?
Yeah. Just double click on the value. That's interesting. What's going on there?
I don't know. I made this 12 here.
Okay, no. So, all right. What you've done is you've dimensioned it twice.
Okay.
You notice that the second dimension is actually in brackets. So the one down the bottom there is in brackets. What that is a driven dimension. You can't actually have two dimensions controlling the same thing. So the second dimension you can't control. You can't change that. So you just want to delete that second one because it's not doing you any good. You only want one. And click on, when you're trying to dimension a circle, click on the outer edge of it.
Oh, okay.
Yeah, just for its actual diameter. Yeah, and click.
Okay.
And there you go. You can put in your.
Okay, so how do I make it move? Because you made it move by typing in values.
So first thing you're doing is you're dimensioning the size of the circle. So how big do you want it to be?
Well, we're going to go with 12.
12? Okay.
Yeah, just the number I just picked out there.
Okay. Just type in 12.
Yep.
There you go. All right. So now to do the dimensions again, you're going to want to hit the D key because your dimension icon's gone away. There you go. Now you're going to click the center. And I was dimensioning to the origin. It's a cheat or a hack, but you can dimension to any one of the sides. Dimensioning straight to the origin, though, is
okay. So I press in the center, and what do I do?
And then press in the center of the origin. So if you hover over the origin at the X and the Y axes, that wonderful little black and white circular icon there in the center.
Yep.
You're not there. So that's the center of the circle. That's not the origin of the drawing.
How do I find what the origin of the drawing is then?
Down and to your left, slightly.
Oh, you mean right here?
Yes, that's the origin of the drawing. See that black and white little symbol?
Yep.
That's the origin. That's the origin of the drawing.
Okay.
Think of it as a base point. It's the reference off of which everything else is referenced.
Okay, so it's basically the starting point.
It's the starting point.
Okay.
So wherever possible, you need something in your drawing referenced back to the origin. You can then reference all kinds of things off of other parts of your drawing. So, but in order to get your model fully constrained, you have to have at least some part of your model connected to or on or dimensioned from the origin. And where you want that origin to be, right now when you're doing, if you do a single model, you're going to do a small little cube like this or whatever, you're going to print it out, the origin's not going to matter very much. But if you ever get into more advanced stuff where you're doing assemblies and you're putting things together, it's worth putting some thought into where you want that origin to be. Because that origin can also be a tool for helping you to align parts that you've created.
Okay.
But that's a topic for another day. That's a little bit more advanced than what we're after here. So let's just get you making a dimension from the center of your circle to the origin.
Okay, so I press D.
Yep.
And then.
So click on the origin, and then click on the center of the circle.
Okay, center.
Yep. Circle and the center of the origin. I think. Yep. There you go.
There we go. And I can change that to be 12.5.
Through center. Yep.
That's not what I want.
12.5. Yeah. There you go. So that's center.
I click that again. Yeah. Press D.
So the reason you have to do more than one of these. So we've given it one dimension. That's locked it in one place in space. The other dimension now is going to make it fully constrained. The only reason this is fully constrained here is because it already knows where the plane that it's being drawn is on the side of that square. So it's got 3 dimensions in space, which locks it. So there's 6 degrees of freedom to an object. You can move left and right. You can move up and down and front and back. But that's 3 different axes. So by adding these 2 dimensions, and we know the plane that this is on, we've now locked down all 6 degrees of freedom.
Yeah, now we want to hit E for extrude, correct?
E for extrude, yep.
Okay.
So now select the profile that you want to extrude.
Which is this profile right here.
Circle, yep. There you go. Now you have the option here to by default, if you do rotate the view, so press Shift and middle mouse click and just drag. There you go. So you can. So that gives you your orbit.
Yeah.
So now you can see
the arrow is sticking out.
The arrow sticking out. That's where it's currently going to go. So if I want it to go the other way, an easy way to do that is to give it a negative value. So I could tell it to so distance, instead of telling it I want it to go 10 millimeters, I could tell it I want it to go negative 10 millimeters.
Yeah, you just did right now.
And you'll notice that it automatically selected cut at the bottom. It automatically changed that to cut.
Okay, yeah. I don't see the cut. Oh, yeah, cut. Yeah, operation cut.
It automatically recognized that you were going to cut the body, but you always want to look at that because that's probably the one gotcha. That if you don't watch what that's doing, sometimes it'll select a cut when you actually want to join something, or funny business will happen, or you want a new body and you end up accidentally joining it. It's kind of useful to keep an eye on what's going on there and make sure that it's going to do what you want. When you're happy with it, just click OK.
So if I really wanted to say I wanted it to be 50, I could do that too and just have and then that makes like a pipe outward, I guess.
Yep, absolutely. And you can see now that it's switched to join.
Oh, yeah, okay.
So what that's going to do is so if you were to do that, that's going to join it. The other thing that you can do is if you have 2 objects where they're intersecting, intersect is weird. It will kind of do a partial cut and a partial join. But the other one that's interesting here is new body. So if you wanted to create this as a separate body, you could do that.
So would I just go into here and just select new body, correct?
New body, yep.
Okay.
And if you did that, it would be a separate entity It's still locked down, so you wouldn't be able to move it because it's still attached to the plane that it was drawn on, and it's still got dimensions from the origin. But it would count as a separate body, so it could be exported as a separate piece.
Okay.
So let's say you were making something to go inside of something else, you could do it this way.
Okay. So what is a new component then for?
So a component versus a body. A body is just that. It's a watertight, solid object. A component can be made up of multiple bodies. So that's really kind of useful if you're trying to create a pseudo assembly within one document. You can directly create a new component. But typically what I'll do is I'll create my bodies, and then I'll select them and add them to a component later on as another step. But you can do it right here. It's an option.
Okay. So now that I'm thinking of this, say if I wanted to make, I'm just saying this right now. Say I'm looking at this and I go, oh dear, okay, yeah, I want that to be sticking out 50, but I made a mistake on the block. I want it to be a rectangle. How does someone go back to fix that?
Okay. Well, first off, let's finish this by clicking OK and exiting out of that. Okay. So if you want to go back and modify the rectangle, down at the bottom there's two ways that you can access this. On the left on your design tree, you'll notice that you've got your two sketches. So the design tree up higher.
This tree right here. Okay, yes.
Yep. So there you'll see sketches near the bottom.
Yep.
So your first sketch, you could right-click and edit sketch there. And you were already on the other way to do it, which is right down at the bottom on the history.
Yeah, now, if I click on that, would that revert all the way back to the beginning?
Yep, so right-click on that right now.
Okay.
And then edit sketch.
Okay.
So now, if you change that one dimension there, make it 35 or something.
Yeah. 35, you say? Okay.
35. Yeah, why not?
I was thinking 45, but it's okay, 35 then.
Yeah, hey, go ahead. It's your drawing. Sorry.
That's okay.
And then just finish sketch.
Okay.
Over on the right-hand side on your sketch menu there.
Or could I just? Oh, okay.
There's actually two places you'll see it. Finish sketch is on the top ribbon. There's a big green check mark at the.
Oh, right there. Okay.
There's there. And the other place that it was there was a pop-up window to your right, but.
Okay. What did I just do now? I guess I
just
just
press and hold shift if you're trying to orbit.
No, I brought up this plane. How in the heck did I do that?
Oh, you just selected it. Just hit your home button. And...
Hit home? Okay.
Yep. Mm-hmm. There you go. So now you'll notice you've got a rectangular cube.
Yeah, I almost kind of like built a hammer in someone's sense.
Now right now, that didn't affect the rod that we made sticking out of there because we referenced that from the origin. If we had referenced that's the position of that rod off of the top line of the rectangle, it would have moved.
Oh, okay.
Yeah. So where you reference something to, where you dimension it to, can be good or bad down the line, and we're starting to talk about things that are going to make this really powerful later. Right now, this is more than good enough, but later on down the line, when you want to be able to make something parametric, which means that you can set parameters for its size and just adjust the parameters and all kinds of other things, compensate automatically, you'll want to put some thought into where you reference dimensions from in case you change those values. So you want to have some idea how those values may be manipulated. But that's kind of a power tool for another day.
Okay. So say if I wanted to take this part out. Mm-hmm. Now I know we're getting a little bit more advanced, so bear with me, folks. I know we got a couple watching right now. So what if I was to take the handle? Mm-hmm. Say I wanted that to be like a handle instead, where I could put the handle and screw it in rather than it being just a solid object. printing.
So you want to do this as an actual part. Okay. I would suggest that we go back to the defining. So on your timeline down at the bottom.
Okay, to the first sketch.
Nope, the final extrude, which would be our so on the timeline. You're currently on the design tree.
Oh, I'm sorry.
You're going to be on the timeline.
Timeline.
The bottom. Yeah. Timeline. Right click on that. Yep. You selected the right thing. You want to right click on it. No, not there. On the
timeline. Sorry. I'm jumping ahead of you. I do apologize.
No, it's okay. It's okay. Now we're going to edit feature.
Okay, where's the edit feature? Here. I don't think it brought it up properly. Hang on a second here.
Yeah.
It's bringing up like this weird tree circle thing here. Let's try that. Right click. There we go.
There you are.
Edit feature.
All right.
Okay.
So let's actually change that join to new body.
Okay. New body.
Now
okay.
Click OK.
Okay.
So now, if you expand on the design tree on the left-hand side, if you expand that that tree, you'll notice that you've got multiple bodies now.
Oh yeah, there's bodies right there. Okay, yeah.
Yep. So now
body
you've got
one and body
two
two.
different bodies. So let's click on body 2 and disable the view. So just click on the little eye next to it. So we're not going to see it for a bit.
Okay.
All right. So now what we're going to do is we're going to go up to the top menu. You'll see a create. Under create, there's a something that looks like a hole through the. You're almost there. That one. So now, if we click on the face where you want this hole to begin.
Okay.
That's not a face.
Oh, don't worry. I'm just trying to turn around here to get the face here.
Yep.
Okay.
Click on that face where you want it to be. Just anywhere on the face. Okay. So now there are a bunch of parameters that have come up, and this is I'm going to have to follow along here. So we have parameters like the face. You've got the face selected that you want to put it on. Now it wants 2 references. So up near the top of the dialog, you'll see reference 1 and reference 2, and they both say select. So the first one, I'm going to select, you're going to select an edge to be your reference.
Okay, so I would just tap on the side there.
Yep.
It gives me a number.
Yep. So you can set that to, remember 12.5 was our halfway mark.
Yep.
12.5, not 125. And now you're going to select your second reference, which should be, yep, exactly. Now
we did this at 35, so 35 divided by 2 is what? Yep, we just lost him again. He'll be back. Let's see. So if it's 12.5, this would be, I think, 22.5, if I'm doing my math right. Is it 22.5?
I think it's 17.5.
17. Oh yeah, because we only want to go by 5. That's right. And we just lost him again. He's having camera issues. Okay.
Yep.
I hit enter by accident and then did this. Is that correct or wrong? And we lost him again. 7 connections issues, my friends.
All right, so I've just stopped sharing my actual screen, so that maybe that will help. I have a feeling that Fusion 360 is starting to.
It's starting to cause issues again.
Yeah. So
it just disappeared.
Hmm?
All of it just disappeared. What the hey?
It looks like you've exited the whole tool.
Oh, snap.
So you go up and start the whole tool again.
Okay. I want this. And I want to go to...
Actually, I think you might actually have escape out of that. And shift center mouse button to orbit. Oh, okay. We're seeing your second body again. What's going on? Oh, you went back in time and merged the body.
Yeah,
So
I went back to fix it.
So you need to go forward again if you want to, because it's now as a no. So
Edit feature.
top right, top left of your screen, you've got forward and back buttons up near the save icon.
Yeah, redo and edit.
Yeah,
feature?
So you want to redo. I would suggest you redo as far as you can.
Okay.
Okay. So now you've got the separate body again. So now we can go and do the whole tool.
Yeah.
On that face.
Sorry, I'm just.
The whole tool is a little bit persnickety. If you don't give it all the information you want, it won't do anything.
Yeah.
Persnickety. That's not. It's a fun word to say, but it's probably not the best choice. It's particular. It wants certain information in order to be able to generate the hole. Now, if you're just trying to put a simple hole through something, extruding a cylinder through it, just draw a circle, and that's really simple. But if you want to do something that's got a chamfer on it, that's down by a certain angle, got a tape, a drill point angle at the end of it, threading.
Damn it. That's not what I wanted to do. Let's see, body number 1. Why can I not see it? I accidentally clicked and I enlarged and it zoomed in on an area, which I didn't want it to do.
Okay, click your home button.
Oh, that's good. Oh, there we go.
Always a good way to. So you probably want to turn off the view of the second body, because that's going to be in your way where you want to put that hole. So now you're going to go to your hole tool.
Okay. Sorry, I'm just getting into the view of it. Hole.
And then select the face that you're putting this on. Yep. Okay, so now we've got to redo those references.
Yep. And then this one. That we're going to go with 17.5. Hit enter, right?
Yeah. Oh, be careful with. That's what you did. I was just about to say, be careful with enter in this module, because it'll click the OK button on you.
Okay. We'll do that again.
You don't want to use enter. You want to just click out of the box to the next one. That's what happened to you.
Okay.
And a lot of if I remember correctly, SolidWorks will do that to you, and so will Inventor, and it's.
Okay.
I've used quite a few different CAD packages, and that's not uncommon with the whole tool.
Okay. So now what am I doing next?
So now you have shape settings. Now the shape settings start off with the extents, which is how far you want it to go. First thing you could do is set a distance. In this case, that's probably what you want, but just to show this off, you can click through all at the bottom, and it'll go all the way through your part, so no dimension required. Or the other one you can do is click 2, and then you would go and select another reference. So let's say you had something mating inside of here already, so you had an object coming up inside, and you were drawing a hole through, and you wanted the hole to go only up to that point. You could go into your model and select that point, and it would go to there, and it would stop.
Okay. So we want to.
Right in this case, distance, I think, is what you want for what you're trying to do. So now you've got your hole types here, and we're gonna go for a simple hole.
So do we want counterbore, or do we just want just simple hole? Okay.
Yeah, simple hole, and then you're going to do tapped, because we want. Thread offset's going to be full. Your drill point, let's just for the ease of this, let's say if you change the drill point, you notice what happens to the drawing below it. You change it to flat.
Okay. Oh, it just makes it flat at the bottom. It doesn't give it like a little taper at the end.
But this again would apply to the tooling that you've got. So if you've got if you're going to use an end mill in a CNC machine to make this hole, or you're going to 3D print it, you can make the bottom flat. If you're actually drilling the hole, you need the drill. But because we're going to 3D print this, more than likely, we're just going to make it flat. It's going to make it nice and easy for us.
Okay.
So then you've got some dimensions there, and it gives you a choice of how deep do you want this hole to be. Well, let's make it 12.5 for depth.
12.5?
Yeah.
So undersized, I'd say 12.5?
Yeah, so that's the top. No, not there. Oh. Not there. Right there, yes.
Oh, okay. Sorry, I thought you meant the one down here I was thinking of. Yeah. Okay. So
yeah, the size, now we are probably going to want to choose, it's automatically picking here for me size of 12 millimeters for isometric. So M12 by 1.75, that's a realistic thread.
okay.
Yeah. So right hand, you could change it to a left hand. And then down at the bottom, there's a little expandable thing that says objects to cut. If you had multiple bodies that this could pass through, you could tell it, oh, don't cut this one. So in that example I was giving before, where you had something up inside and you wanted to put a hole, let's say you wanted the hole to go right through, but you didn't want it to cut through this object, which was not like that was meant to be inserted in there, but you wanted the hole to pass right through, you could tell it not to cut that second body.
Oh, so it only cut the one body, not the other body.
Yeah.
Interesting. Okay.
That's a right now you don't need that. So if you click OK now, we should get a hole.
Okay, so size 14 is okay to leave at 14, correct?
Yeah, go for it. Yeah.
Okay.
So you might need to change the size of your actual object later, but now if you use Shift and D and orbit that a little bit, you'll be able to see the thread pattern on there. What the heck?
I hold it Shift D and then I accidentally hit the mouse key. Hit right instead of left, so I might have undone it.
Yeah, I think you've undone it.
So do I just hit back?
That's undo. You want to go redo. Yeah.
Redo. Okay. There we go.
Yeah.
So Shift D, you said?
No. Shift and middle mouse button.
Oh, middle mouse button. Sorry.
I might have actually said Shift D. My mistake.
Oh, okay. Yeah, I can see the cutout. Interesting.
Now, there's a problem with this. This is a representation of that threading. This is not actually that threading. If you actually want to 3D print this with that thread, it has to be done in an entirely different way, and that is a more advanced video. Because this is a visual representation. This is intended more along the lines, if I'm going to CAD this as, okay, I'm going to tap this a certain size, it'll draw it in and it'll show it to you. And part of the reason we do this is visual representation is it's a lot lighter on the CAD model. Imagine the helix being created for every single hole, and all of the little points and triangles and all that necessary to model that, and then put 300 screws into an object that you're making and try and rotate your model.
Okay. Yeah, it sounds a little bit much.
No. Yeah. So this saves weight essentially in the CAD model, and for traditional manufacturing, this works really well. For 3D printing, when you actually want to generate that screw thread, we're going to have to actually physically make it, which is there are some ways to do that in other CAD software. This is not letting you do that. And it's, I don't remember, sorry. There is one, if you go in and select your hole tool again. Sorry, not at the top. If you go down to the history and right click, edit feature.
Yep.
Down near the bottom, right above objects to cut, there is a checkbox.
Objects to cut.
Yeah, so you're going to have to scroll down a little bit. You're not seeing the whole...
Oh, there's object to cut. There it is. Yep.
See the modeled button? There's a
Modeled?
little radio button.
Yeah, I do
Check
see a
box.
model that's like a check mark.
Yeah, check that,
Okay.
and then click OK. And then it will actually physically model. So now you're going to see a difference in what those threads look like when you go and look at them.
Shift.
Before it kind of looked a little bit like a picture. Now those are actually modeled threads.
I see. Interesting.
So yeah, not every CAD package has this option. Although most of them are starting to add it because it's additive manufacturing has brought in a new problem. But if you do this on a grand scale, it's going to cause you problems. So if you're modeling something for a more traditional manufacturing process, you wouldn't want to do this because while you got it turned, run your mouse over that section. See how it's selecting all the coils of that.
Oh, neat.
Yeah, so that gives you an idea of how complex that model is. Individually, for one hole, it's not a big deal, but for a couple hundred holes, that's a lot of extra complexity.
Okay, now why am I seeing these lines light up here and here?
Because it's showing you both the hole that's been cut. So the cylinder is being lit up, the edges. This is essentially made up of a whole bunch of different bodies. There's also a guide rail usually.
Okay.
These things. The Fusion 360 is one of the tools that it's the tool I use the most often now, but that's not saying a lot. I don't do a huge amount of CAD modeling right now. When I was doing the most CAD modeling, I was doing it in SolidWorks and Inventor. Did some with Creo. And learning all those different packages is like I can pretty much figure out how something works just from I've seen 3 different ways that something can be done, or the similarities or dissimilarities between them. Just like that model tab, I wasn't 100% sure that I could do that modeled thread because I haven't needed it for anything that I've done in Fusion 360.
Yeah.
But I knew where to look for it.
Okay.
If the option was there, it was going to be on that menu, and it was. So.
Yeah. So looking at this model now, let's just say, looking at this here, and we're just going to be going over a new model, say next week.
Mm-hmm.
So, say if I'm happy with this, how do I can bring in that other body now into this?
Yeah. Let's just turn on, and that other body is still there. You're just going to turn on its visibility.
Okay.
So now, obviously, we can see that we might need to adjust its position, which we can go back and we can do that in the second sketch, which created that. So that's the feature that one.
Yeah, that's what I want. Right click on it. Add sketch. Okay.
So you can change your offset to 17.5 there to put it in the center.
Yeah. There we go.
All right. Now I'm going to teach you something. I'm going to show you something fun. This is actually a little bit of an advanced trick, but it's something you can make use of right away.
Okay. So now, how do I go back to the
finish sketch? Yeah.
There we go. There we go. Okay. So now that we have this handle in it, does it copy what the threads are?
Oh. No, we have to add that onto it, and it doesn't actually go in it. If you remember, it's sitting on the outside of it.
That's right.
So we're going to have to add that thread, but I'm going to show you something handy first. So if you go to the first sketch that we did for the hammer itself, and then right-click on the first sketch.
Got it.
Yeah, edit sketch. So what I'm going to get you to do is hover over. See the height there? Just hover over that dimension. See the number in front of it? I can't read it.
It says D2.
D2.
And
that's all you need is D2. So, so if we exit
it says D2 35. Sorry. millimeters.
That's telling you it's dimension. It's the second dimension that you created,
Okay.
and the value is currently 35 millimeters. So if we finish the sketch, we're going to exit out of here.
Okay, so hit finish sketch.
Yep. Now we're going to go edit the second sketch again.
Okay, so go to second sketch.
Yep.
Right click on that.
Edit sketch.
There we go.
So now I want you to that dimension that you just adjusted.
Yep.
Go and click on that. Double click on it.
Oops.
Now I want
Number
you to type.
or
I want you to type. I want you to type D2.
Okay. D2
slash 2.
2.
So what that is dimension 2 divided by 2. Hit enter.
Okay.
Congratulations, you just created a parametric function. That will automatically be placed in half. It will automatically be half the distance of the total length of that object. So
so I can go back to sketch 1, change it again, and it'll still follow it.
If you change the dimensions of sketch 1, it will still place it in the middle. It'll place it in the center.
Nice. Now, would I need to change both of those values to be D2?
No. So you go back and you change D2. So what this dimension is now doing. So if you hover over this dimension, like you did before,
what I'm wondering is, wouldn't I have to change this if, say, I made it longer this way?
You could, but so I want to show you how the power of this dimension. So we're only really working with that dimension.
Okay.
So if you hover over it,
go back to
hover over this dimension that you just did here.
Mm-hmm.
See its number. So what's its D number?
It is D something. Hang on. D9. Then the 2 dots, D2.
So what this means is that dimension 9 is being parametrically, it's being driven by a parameter or a function from dimension 2. So if you change dimension 2, dimension 9 will automatically adjust.
Okay.
If I wanted it to be the exact same dimension, so let's say I wanted two things to be the same length, I can set the dimension of one, and then I can set the other dimension to just be that one. So I could say, so D2 is 10 millimeters, and I go to make the dimension 3. Oh, I want that to be 10 millimeters too. I just type in D2, and it will automatically change. Every time I change D2, D3 will also change to the exact same value. In this case, what we did is we told it to divide the value of D2 in half, which gives you the center. So D9 is being referenced from D2. If you wanted to do the same for the other dimension down here, we would have to go back and get the dimension off that. But it works between different sketches. Most commonly, I'll use this in the same sketch. So like I'll use it to, so like if I don't want to, if I want to be able to come back in and change a parameter, like an offset of something, like I've got several little things offset, I'll put in all of the dimensions and I'll reference them off of each other. So I only have to change one of them, and then boom. That's the beginning of parameters. And there's another step, but we'll save that for the next video. Because we can take parameters even further by setting up actual named values ahead of time, and then modifying them, and you'll reference the named value instead of a dimension number. But this is getting you into using a function to drive values.
So how do you save a design? Like, say if I wanted to save this right now, I want to go back to it later.
First off, I would recommend finishing the sketch before you do that. So just a finish sketch.
Up here, finish sketch.
I don't know that you have to do this. This is just, for me, this is good practice. I don't want to be in a dialogue, in a function, in a sketch, modifying something at the point that I save. Now, one thing about Fusion 360 is it's auto-saving the background, but right now you're untitled. If you go up to the little save icon up the top left corner there, there's a little diskette option. Yep,
I see it there.
Click on that. And this is going to pop up a user save dialog, and you can change where it saves. Right now, your default folder is my first project, but it's so you just give it a name.
We'll call this test build 1.
Test build 1. Okay. And then you just click save.
Okay. Save. Done.
Yep. So, and now you'll notice it's named up at the top.
Oh yeah, it said number 1, version 1.
Yep. So, and you can force it to do a manual save, but it auto saves after most of your changes.
Okay.
Now, you asked me at one point about editing STLs and bringing in another STL because of the way that works. One of the reasons that becomes very problematic is that nice little history feature that we've been using down the bottom. In order to use the function to import the STLs, which you have to import them as surfaces, you have to turn off the design history in that document in order to do it, and it basically means you've got no undo. No undo, no redo, no.
Oh, come on. I'm selecting you to move. It doesn't want to move.
Shift and middle mouse to orbit.
Oh, shift middle. Yeah.
So most professional CAD software uses the middle mouse button, which on modern mice can be a real pain in the butt because it's also your scroll wheel. However,
yeah, so that's your middle button right there, people.
Yeah. Your scroll wheel is your zoom. So let's just moving around. So if you use your mouse, press and hold with the middle mouse, and that's going to do what we call pan. Well, that's with shift. So without the shift, if you just click with the middle mouse, that's panning. Okay.
Yep.
And then shift, and that is orbit. And then your middle mouse button gives you, or your mouse wheel gives you zoom. Now I'm actually using a CAD mouse. You can buy CAD mice. They're not cheap, but they've got an actual separate middle mouse button. So I have a 3-button mouse plus a scroll wheel.
Yeah.
So.
And if you really have the money, you can buy a space mouse, which is even more particular.
The space mouse is kind of. Do you want to show what the space mouse does?
Sure, I can.
I need to share my screen again, don't I?
Yeah.
Application.
Okay, so we're going to add in his instead of mine right now. So you're looking at Mr. Barrett's screen right now.
So I was just following along with the whole tool earlier, so you can see I've got a kind of a funky intersecting thing here. But now I'm not using my mouse to do this. This is being done by my space mouse. So the space mouse lets me just completely control something in 3D space. And I'm not really fantastic with this yet. I got it a while ago. You can get really quite fast with these. And it'll let you just sort of bring up something and look exactly, I want to go right there on that little detail, and I want to modify that. And it can be quite useful. I found it easier to get used to using at least rudimentary use of the 3D CAD mouse, the space mouse, more so than using the discrete 3-button mouse. I was so used to using a 2-button mouse with the scroll wheel in the middle.
Yeah.
That transition was actually, it's still hard. I actually find myself using the mouse. So this is my current mouse, but I find myself holding it like this because I've always dropped this finger off the side, so I don't have it on the right. I have to move my finger to the right mouse button just because I can't quite get used to having all 3 fingers up there. It's just.
Yeah, I think holding a mouse like this doesn't feel right.
Yeah, it's well, we all have habits and ways that we hold things, and I've found the transition to having that third discrete button difficult, but yet when I'm using CAD, it's like second nature. Like I'm just like this is now using the mouse instead of the space mouse, and this is pretty easy for me. The one thing that's a little bit wonky is from CAD package to CAD package, and even into the Cura or Thingiverse, the button configurations change. So it takes half a second. It's like, oh yeah, this one's different. And it's like, oh, it's right
Yeah.
click here. And
Like I prefer my gaming mouse since I've gotten this one.
yeah,
I'm just using a Black Mamba, which is a gaming mouse. But what I love about it is that I can adjust the DPI so I get that sensitivity I want
yeah,
when I'm using my mouse, because I find that a lot of times when I want to design, when I'm playing with something, I want that extra speed to be there to adjust with my speed.
that is something that again, the CAD mouse gives you that kind of freedom. Let's
Yep.
see if I can bring this up here. Show you guys. Don't know how well it's going to like me trying to do this.
I'll zoom in on the screen so we can see what we're doing. What you're doing.
Oh, I'm going to actually have to share this as a. Sorry. I have to share this application window because. Okay, here you go. So this is the control for the CAD mouse that I have. So I can change the speed. I can program some of the buttons on it if I want to change their functions. And there's quite a few options. And I also have control of the universal receiver and the space mouse itself.
Looks like
so
those things need to get charged, eh?
I actually did charge the mouse up a little bit. You wouldn't believe how long these things last, though. Like they last months.
Oh, even with that
on a
little bit
charge.
of battery power, eh?
It's time to charge these, but you know, like these haven't been charged in probably a month and a half, maybe 2 months.
Okay.
Like the charge is quite good on them.
Yeah, I find with this mouse I have to charge at least twice. In 2 days, I need to charge this thing up again. So,
and honestly, the space mouse itself is if I was to turn it off all the time when I stopped using it, which I really should, the battery would last a lot longer. But that's part of the reason why the mouse is lower than the space mouse isn't getting used as much. But I did leave it on. Otherwise, the space mouse would be almost full, and the CAD mouse would be the one dying because I use it constantly and it always stays on.
Yeah.
And you also got a very nice. What I've got is the wireless CAD mouse combo, and you got a really nice mousing surface, which is dusty, but it's a hard kind of card, but it works really well with like just about any mouse. But that's nice because I can shove that in my backpack, and both of these came with little carrying cases. So this is fully portable. I can take my my fairly powerful, basically gaming laptop, and these.
Oops, we just lost him again. He'll be back in a second. So we'll just wait for him to reconnect, add to stream.
So is that
you gotta stop closing your windows?
Is that the equivalent of you've got more time? Just stop that. Just drop me.
No, you exited out. Your device said not connected.
I don't know what's going. I do have some internet connectivity issues, and this is all going over my Wi-Fi as well.
Yeah, which is not always the greatest, but.
I don't know if you can. My setup here is a little bit unusual. I am sitting in an armchair instead of a computer chair, and I've got a custom-built little desk that I designed and built that rolls around. It's mobile.
Yeah.
That holds desktop computer and my laptop. And this is my sort of temporary workspace for this tiny little room that I'm living in. It's worked reasonably well, but there's some peculiarities.
Understandable. But anyways, I just wanted to, since we are near the end, we'll be here next week, 7 p.m. Eastern Standard Time. We're going to do these for 1 hour. If you have any questions or anything like that, feel free to message us. The best way to get in touch with me would probably be through the Discord. As we have the CMP channel itself, which is on 90, which YouTube is more for everything I do over there is where I use YouTube the most. So if you have a YouTube account, if you just look up Canadian Maker Project on YouTube, you'll be able to find the channel and you'll see all the designs and everything else that we do there, which is just the 3D printing stuff. This is going to be primarily for design. So if you guys are interested in watching us talk about me understanding CAD work, this is a great way for you to, follow us here. And yes, these videos will be popping up on YouTube once I get the ability of moving those videos over to YouTube. But if you want to already get involved, we do also have the Patreon and we have a Streamlabs account, which all go to the PayPal account. I haven't set up the PayPal me account yet, but if you want to support the channel, that is one way you can do it. Also, I know we haven't been partnered as of yet, but once we are partnered on Twitch, then you guys can start sending bits and doing it that way also. But for now, we do have ways that you can still support the channel.
Subscribe. Wait.
And don't forget, we also have a Twitter account. So if something says that we can't do it this week, I'll make the announcement on Twitter, which is the best way to follow all the information that goes on for the channels. Because we have multiple channels. It's just what it is.
It was a lot of fun.
So with that being said, I'm just going to leave the Discord on in case anybody wants to get on Discord with us. So that's the best way to follow it. Just type in discord.gg/H capital T X capital V then DHW. Yeah, I know. I wish Discord would give us a way just to put in, your initials or whatever you want to make it shorter so that it's easier for people to find your find Discord channels, but maybe they'll start doing that in the near future. With that being said, anything else that you want to add to this before we disconnect, Barrett?
Well, I actually just wanted to ask how that went for you.
Well, I learned a lot, honestly. Like I said, this is going to be repetitive, redoing it over and over and over to get it locked in my head. So as we go on, we can do it again, and I'll remember more again. Yep. Do it again, and I'll remember more again.
Yep.
It's just going over it, because I find, even though, we're doing this on Twitch, but I want you guys to also have a copy of Fusion 360 to follow with us. If you've never used Fusion before, it's easy. It's free to get right now. All you have to do is go to just look up Fusion 360. It's made by a company called where's the name?
Autodesk.
Autodesk. It says Autodesk Fusion 360. Just go there, type in your and make yourself an account. It's absolutely free to make. And what you want is personal use. You don't need it for office or work because you're not going to be, unless you're making money with it. Then you want to select the one that you need. What's the criteria right now for the money? I think it's like 10,000 you make.
No. So what you're actually searching for is the hobbyist, which will take you to the personal use account. And as long as you're not making $100,000 a year, they're not concerned with you. When you want to start paying for your CAD package, by the time you've got a business or a bankroll of $100,000 a year off of using the software, you need to be able to pick up the phone and call support. Hey, it's not working. I need help.
Yeah.
So at that point, they really care about you because that's where those lucrative support contracts come in, and you need that at that point. Below that, if you choose not to have that, they don't really care. Your support's going to be might be next week that they get back to you. If you want that higher tier of support, you're going to go and seek it out. And they basically, Autodesk does a good job of that. And Autodesk is not a new company. They're the makers of AutoCAD, you may have heard of. It's been around for a little while. It's gotten really long in the tooth. It's kind of old, and it's still used. It's still out there. Still has its uses. But they also make Inventor, which is another very serious CAD package. Fusion 360 is actually a step below Inventor, but it's kind of a cloud solution, and because it's free to everyone, it's the choice. I actually quite like Inventor as well. And then, of course, there's the competition out there with SolidWorks. But that's Dassault Systems, and, well, they're French.
Yeah, and and also with any of these CAD type of programs, I find that with Autodesk, if you already have a Tinkercad account, you already have access to Autodesk. software
Yeah,
to the Fusion 360.
Tinkercad is an Autodesk product as well.
Yeah.
So yeah, that's another decent point. Both Fusion 360 and Tinkercad are cloud-based, so your files are in the cloud as well as somewhat on your own. In the case of Tinkercad, they're totally in the cloud. You have to download them to your own computer if you want them on your own computer. With Fusion 360, they're sort of quasi on your system, but that's one of the reasons why you don't tend to see Fusion 360 used as much in industry yet. Industry is a little bit afraid of this whole cloud thing because they're really worried about losing control of the files. So a lot of them will take...
I can see a reason why they feel that way, because it kind of opens up holes in their idea. But honestly, I find if I know a lot of businesses now are moving their data to the cloud, which is an interesting aspect to think about.
It's interesting, but it's not without its pitfalls.
That's true.
I came from the broadcast industry, and one of my previous employers was seriously looking at the cloud for storage, and ended up deciding against it because of the legal ramifications. The video files that we had, we were being given rights to. If there was a breach, if we lost control of those files, well, we would have been in breach of our contract with the actual owner of the rights that had licensed us to use them, and that was just a mess we couldn't get into. We couldn't do that. Exactly. There's even a problem with your intellectual property crossing a border. So let's say the cloud server is in the US and you're a Canadian company. Well, now it's not only not in your control, it's governed under another set of rules. So the cloud is... it's something that's coming, though, because the collaborative options that it gives just are out of this world. Like you can have somebody in your London, UK office working with somebody in your New York office who's also working with somebody in Seattle, and you're all working on the same project. And it's like, one guy goes to bed and hands it off to his counterpart, or they're working on different pieces and they're bringing it together live. So you could have the guy in New York and the guy in London working off each other, and the guy in San Diego or whatever is just keeping the files in sync and merging changes. It's the options there are endless, and to get that functionality out of something like SolidWorks is really expensive. You have to pay for their Vault software.
Yeah. Well, we're going to call it right here. But if you guys have... Yeah, pardon me?
I'm rambling. Sorry.
Yeah, you were. That's okay. Don't worry about it. I do it all the time to myself on my live streams. But anyways, guys, people, I want to thank you so much for tuning in. If you're on Twitch, remember, hit the follow button. You don't have to hit subscribe. If you want to hit subscribe, you're welcome to. Subscribe actually makes you have to pay money to use Twitch. But if you are an Amazon Prime customer, you can actually hook up your Amazon Prime to Twitch, and then you can subscribe, and a little bit of that money goes directly to us to help fund whatever we are working on. So that's one way that you guys can support. If you're paying Jim Bowser's money, we don't want him to have all the money.
Well, you're just buying Ron some coffee so that he can stay up and do the editing afterwards.
Yeah, I'm not. Yeah. And a little bit goes to you too, as well, because you're helping us learn all this.
I don't know. I'm helping a friend learn Fusion 360. I'm not too worried about income right now. So.
Well, still, if you're looking for full out designs, you can contact Mr. Barrett. I know he does some design work, so if you have any questions, just hit CMP. Just email me at CanadianMakerProject at gmail.com, and I will make sure that he gets that email, and you and him can you and him, as in Barrett, Mr. Barrett over here, can collaborate and get your design made in case you just don't want to do it. You just don't have the time or whatever. So until next time, everybody, thank you so much for watching, and have yourselves a great day. Bye, everybody.